The last big thing that we're going to do in this chapter is take our acids and do something fun, and that is add them to bases. So we're going to do some acid-base reactions. And I've got here the triangle to look at our acid-base reactions, to look at it at a macro, a particle, and a symbol kind of perspective. So as we look at our acid-base reactions, another word for these is a neutralization reaction. So if I can grab my colors, we're going to see that we have some acids like HCl that react with some bases like our hydroxide here, and we will get closer to neutral, not necessarily to 7, but as a result of a neutralization reaction, we get closer to 7 than we were before. So if you were to do this in a lab, let's say that you take a clear solution of sodium hydroxide and a clear solution of HCl, and you mix them together, you're not going to see anything exciting, hopefully. All that you will see as these two add together is what you won't actually see. It's going to feel hot. So orange is our color for energy sometimes, so it's going to feel hot. Now, if we do want to see something, we can add an indicator. We saw the cabbage earlier, but there's also a lot of synthetic indicators you can get. So you can add an indicator if you want to visualize or see the pH change. So indicators are cool chemicals that change colors depending on what pH you're at. So this is one way you might see this in lab, where you pour one solution into the other. A more technical analytical chemistry way to do this is to maybe take your hydrochloric acid and measure it carefully in a burette. This glassware is called a burette. And then I could mix that with some sodium hydroxide in what we call a flask here. So I might mix the two there, and again, I can add an indicator if I want to see some of the pH change happening there. So those would be the macroscopic things you would see. On a particle level, here's some sodium hydroxide reacting with HCl, and I get water and I get salt. And then the other thing that I get, of course, would be energy or heat. It would be another product. Finally, if we talk symbolically, like what are some ways we write this? First, I'm going to do it in words. So we can add an acid to a base, and what we expect to get is a salt plus water plus that energy. So for example, this reaction here, an acid, HCl, plus a base, sodium hydroxide, gives me a salt, and salt is just another word for an ionic compound, not for table salt, although that's coincidentally what I have here, plus water, plus if I looked up how much energy I actually got, go back to chapter 6, the delta H for this would be negative 56 kilojoules per mole. And that should make sense that it's negative, right? Because negative means it's exothermic. And that's what I felt up here. When it feels hot, that means your reaction's giving away heat. So that is an acid reacting with a base. And I end up with something really neutral and boring, which is water and a salt. So both of those are much more neutral than my crazy acid and my crazy base. And if you have exactly equal quantities, you'll end up at a pH of 7, but really the take home here is that the pH is just going to be closer to 7. So not exactly 7 necessarily, but closer to 7. So that is a way to see the reaction, see it as a particle, and then see it with some symbols. Next up, we'll do some solution stoichiometry to actually put a bunch of numbers onto these problems.